All right, today we're going to look at periodic functions. Specifically, we're going to be looking at sine and cosine. So right now on the screen, I have a graph of sine, and the reason it's called a periodic function is that it just keeps repeating over and over. So I can keep scrolling and I'm going to see the same picture. In fact, without the scale on the x-axis being labeled, we would have no idea we were moving. All right, so there are a few things about periodic functions that we want to look at. One of them is trying to figure out how often do they repeat, and that's actually called the period. So for sine of x, which I have in front of you, we start here at 0, 0. We go up to 1, back down to 0, down to -1, back up to 0. Between 0 and 2 pi on the x-axis is the period of this sine function. All right, and this is our parent function. In general, we find the period by doing 2 pi over b, which I'll explain more about in a little bit. Now, if we look at cosine, cosine looks like this. Some of you may have spotted the difference. Some of you may have missed it. I will compare them side by side. But once again, it keeps repeating. All right. And so these are called wave functions. And I'm assuming you understand that because they look like a wave. Now, this one starts at 1, comes down to 0, down to -1, back through 0, back to 1 before it repeats. All right. And if we want to look at both of them together, they look like this. So really the only difference between these two is how much they're offset by. We could actually move a sine graph so that it falls on top of the cosine and vice versa. We are not going to do that today. We're going to look at two very important features, and they are going to be the amplitude and period. Now, for amplitude, I'm going to be talking about the sine function, but everything I say about amplitude applies to both sine and cosine. I will do period under the cosine function, but once again, everything I do there still applies to sine. So they both have the exact same way of finding the amplitude and period. So starting with the amplitude. Amplitude is really just a way of saying how big are these waves? So you have to consider where the middle is, our midline. In this case, it's y equals 0, our x-axis. From there, we can go up 1, so amplitude's 1. If we want to go down, we would say we could go down 1, but the amplitude is still 1. And I'll explain a little bit more about why I'm saying down 1 is still an amplitude of 1. Now, if we want to change it, we can simply do a vertical stretch. So if you think of all the other functions we've done, you multiply by something. So if I say 2 times the sine of x, we have now made the amplitude 2. So from this midline, it goes up 2 units. It's now twice as tall as the sine wave. If we go in the lower direction, it's still twice as tall. So in general, our amplitude is the absolute value of a. A is the number that we're multiplying our sine or cosine function by. So if we put in 5, all of a sudden, our sine wave is 5 times taller. So instead of going up through at 1, you now go up through at 5. All right. Well, what if we try something smaller than 1? What if we try a 1/2? Well, now, remember guys, the red one's the original. Now our graph is half as tall. So instead of at pi over 2 going up to 1, it's only going up to 1/2. All right. So amplitude, in general, is the absolute value of a. Now, I defined it saying that it was from the midline to the maximum or midline to the minimum. Another way of saying this is half the distance from the max to min. So on the parent function, let me get rid of that one, we're at 1, and for the minimum, -1. That's a distance of 2 units. Half of 2 units is 1. It doesn't matter which way you want to look at it, but it's always the absolute value of a. Now, to show you this, I'm going to put back that sine of 1/2 x. I'm sorry, 1/2 sine of x. I'm going to put a negative out front so you can see what happens to the graph. All right. One of the things you should notice, it didn't get any taller. It didn't get any shorter. It's still an amplitude of 1/2. It's just upside down. All right. So the amplitude is still 1/2, even though a is a -1/2. So make sure that when you are asked what is the amplitude, you do the absolute value of a. So do not give a negative answer for amplitude. All right. Now to look at period. If you recall, period is how often the graph repeats. So here's my cosine. I'm going to go back to the beginning. So if we look at this, I'm going to stretch this out so you see exactly one period. That's one full period of cosine. We started our max. Sorry about that. We started our maximum and we go down to our minimum and back to our maximum. All right. If we want to change the period, what we're going to change is the inside. Instead of saying the cosine of x, we'll say the cosine of b times x. We'll replace b with a number. All right, so what I'm going to do is start here. So this is with b equaling 1. And if I change it, if I go up to b equals 2, now what happens is my graph has a shorter period. Instead of taking 2 pi to repeat, it's repeating at pi. The way you come up with that is that it is 2 pi over b. So in this case, b is 2. I'm doing cosine of 2x. 2 pi divided by 2 is pi. So it's going to repeat every pi units. Another way to look at that is if you look at the original parent function, I have one cosine wave for y equals cosine x. But for y equals cosine of 2x, the green one, I have 2 full cycles. So you can think of b as telling you how many full cycles you will have between 0 and 2 pi. But remember, if you're asked what is the period, you're going to do 2 pi divided by b. So I can bring this up. Let's say I make it 4. Now between 0 and 2 pi, I have 4 full cycles. But the important thing for you to find out is what is the period? 2 pi divided by 4. 2 over 4 simplifies to a half, so we have pi over 2. So from 0 to pi over 2, I have a full cycle for my graph. Well, it seems like bigger numbers, I'm getting more waves. So if I go to 10, all of a sudden there are a bunch of them. Specifically between 0 and 2 pi, we have 10 of them. The period is pi over 5. So if I start here, let me turn off the parent function. If I start here and I go until it repeats right here, that point is pi over 5. 2 pi divided by 10. Now, what if we go smaller? What if I put in 1/2? What's going to happen then? Well, at 1/2, let's compare this to the original again. So here's the parent function on top. If you notice between 0 and 2 pi, the parent function, we have one full cycle. For cosine, we have half a cycle. In fact, the period is now 2 pi over 1/2. Now, remember when you're dividing by a fraction, you could change it to multiplying by the reciprocal, or you can ask yourself how many halves are in 2, because you're doing 2 divided by a half. There are 4 of them, so we have 4 pi. It takes 4 pi for it to repeat. So this really stretched out. So whenever the value of b is between 0 and 1, it's going to be stretched out. When it's between 1, I should say when it's greater than 1, it's going to be squished in. So this is going to affect our horizontal stretch and shrink. That's what these b values will do. At this point, you should have enough information to start on your worksheet. Remember, if you're in the Algebra 2 regular, you are not going to have to graph. They are just there for you. For Algebra 2 honors, we are probably going to give you a graph, and you will have to tell us from the graph what is the period, what is the amplitude, and maybe write the equation given a graph.